Principle of calorimetry states that in a closed and insulated environment, if heat is exchanged between two objects, then the heat gained by a colder object should be equal to the heat lost by the hotter object. Since heat is the form of energy that is transferred from a hotter body to colder body, so this in a way arises from conservation of energy. If we take into account the heat transfers between the environment, even then we can say that heat lost by the hotter body should be equal to the heat gained by the colder body plus the heat gained by the environment, and vice versa. Practically, the principle of calorimetry can be used to measure the specific heat capacity or latent heat of a substance with the help of a calorimeter. A simple calorimeter is a small vessel usually made of copper. This vessel is well insulated by surrounding it with a material like wood, thermocol, or even vacuum. This is done to minimize the heat transfer between the calorimeter and the environment. A thermometer is used to measure the temperature of the contents of calorimeter. A substance with known specific heat capacity, usually water, at a fixed temperature is allowed to mix with another substance at known temperature but of unknown specific heat capacity. After some time, the temperature of mixture becomes steady and is the final temperature of the system. As heat gained by one substance should be equal to the heat lost by the other, so we can find the specific heat capacity of the other substance. Note that here we have ignored the heat gained or lost by the calorimeter itself because it is usually very small. However, strictly speaking, we should include the heat transfers to calorimeter as well, which can be included by using directly the mass and specific heat capacity of the material of container, which is usually copper. Often, the water equivalent of calorimeter is specified. That is, the equivalent mass of water that would require the same amount of heat to change its temperature by 1 Kelvin as would be required by the calorimeter for 1 Kelvin change in temperature. This means that the heat transfer to the calorimeter will be equal to this term. Since specific heat capacity of water is very well known, so this notation is often more convenient.